Hello, in this video we are continuing our discussion of section 8.5 on power series. We're on day 2, so we're talking about some different examples. Example 2 says to find the center, radius of convergence, and interval of convergence for the sum from k equals 0 to infinity of x to the k over k factorial. So first off, for our center, remember that we look at our power term. We set it equal to 0. Clearly in this case, that's going to mean that our center is at x equals 0. And as before, for the radius of convergence and the interval of convergence, we will always apply the ratio test. So, setting up and simplifying our ratio, we have the absolute value of a sub k plus 1. Over a sub k. So that's going to give us an x to the k plus 1 over k plus 1 factorial, all over x to the k over k factorial. This is going to give us a k factorial over k plus 1 factorial times the absolute value of x to the k plus 1 over x to the k. The first ratio that we have here, we've done some simplifications with k factorial and k plus 1 factorial a few times now. We know that k plus 1 factorial is the same thing as k plus 1 times k factorial. All of those terms end up canceling. And then the x to the k plus 1 over x to the k, almost everything will cancel. We'll just be left with an x to the first power. So this will simplify to an absolute value of x in the numerator and a k plus 1 in the denominator. Then we look at our limit as k goes to infinity of the absolute value of x over k plus 1. As we saw in the previous example, the x term does not change in terms of the limit, so that can be pulled out like it's a constant for the limit at least. So we have the absolute value of x times the limit as k goes to infinity of 1 over k plus 1. And we know that that limit will go to 0. So we end up with the absolute value of x times 0, which is 0. For any x value, you multiply it by 0 and you will get 0. Well, for the ratio test, we need this to be less than 1, but 0 is always less than 1. In other words, for any x, we will always get that the limit is equal to 0, so it is always going to converge for any x. So this means that the series converges for any x. So then the interval of convergence is all x values between negative infinity and positive infinity. And if we think about this interval being infinite, it has an infinite distance, so half that is still going to be infinite. So the radius of convergence is r equaling infinity. So again, to box in our 3 answers here, the radius of convergence is r equals infinity, the interval of convergence is negative infinity to positive infinity, and the center is x equals 0.